Hello friends, welcome to engineering tutorial. So here we are with another question on error analysis. So here uh, it has been given that the open loop transfer function of a unity feedback system is given by Gs is equal to 100 by S into S plus 1 into S plus 2, and we have to find out the steady state error for the input value given by 5 plus 4t. Okay, for this input we have to determine the steady state error. So here again the normal usual process that you start with finding out whether the system is unity feedback. Yes, then the error constant method is applicable. This is the open loop transfer function, okay, OLTF. Okay, then the input here, it is given as 5 plus 4t, this. So here if you notice, it consists of two signals. First a step, then a ramp. So you have to break it down into two parts and find out the steady state error individually for these two inputs. This signal is composed of step and ramp. For this step signal 5 ut, the value of A is equal to 5. Here for this ramp signal 4t, okay, the value of A is equal to 4. If you remember the general format AT, here it is AUT, which we have discussed in the first video. So always remember the format. So the value of A for this is 5 and for this ramp signal it is equal to 4. So now we will start finding out the error constants separately for step and ramp. So first for this step input, the position error constant, okay, or the position or the step error coefficient Kp is equal to limit S tends to 0 Gs, that is equal to limit S tends to 0 Gs, which is equal to 100 by S into S plus 1 into S plus 2. So we will simply substitute the S with zeros, that is equal to 100 by 0 into 0 plus 1 into 0 plus 2, that is equal to 100 by 0 into 1 into 2, 100 by 0, that is equal to infinity. Okay, so here the position constant Kp is equal to infinity, and as per the formula, the steady state error due to step input is equal to A by 1 plus Kp. Here the value of A for the step input is equal to 5 by 1 plus infinity. 1 plus infinity is equal to infinity, a very high value in the denominator, so it is 5 by infinity, which is equal to 0. So the steady state error due to step input is equal to 0. Then for the ramp input, so for the ramp input, the velocity error coefficient, we have to find out Kv, which is equal to limit S tends to 0 SGS, which is equal to limit S tends to 0 S multiplied with this Gs function, 100 by S into S plus 1 into S plus 2, okay, 100 by S into S plus 1 into S plus 2, SS gets cancelled, so it is simply 100 by, we'll substitute S with 0, 0 plus 1 into 0 plus 2. So it is 100 by 1 into 2, 100 by 2, it is equal to 50. So kV is equal to 50. Now we know that the steady state error due to velocity or the ramp input is equal to A by kV. So here for the ramp input, the value of A here is 4T. 4T is equal to FT when we compare A is equal to 4. So A is equal to 4 by 50, that is equal to 4 by 5 into 1 by 10, 4 by 5 is 0.8, 0.8 by 10, that is equal to 0.08. So here the total steady state error, okay, the total steady state error is equal to the steady state error due to step plus the steady state error due to ramp, which is equal to, for step it is equal to 0, for ramp it is equal to 0.08, which is equal to 0.08 only, the steady state error. So here the main concept was that the input was given in a different way. So most of the students, when they are getting started with this, they get confused, okay, what kind of a input signal is this? So here you have to understand that you have to break it down into two separate signals. This is a step signal 5, constant value. This is a ramp signal 40 with the constant 4 is the slope. Then you have to determine the values of A for each. Then for each signal, step and ramp, you have to find out the error coefficients. Then you have to put the value in the formula to get the value of steady state error. So the total steady state error is the sum of steady state errors due to these individual signals combined, which is this. Okay, so remaining is just the same. Always be careful about whether it is mentioned in the question, whether it is unity feedback system. Then make sure this is the open loop transfer function. By mistake, don't put it in the closed loop transfer function, then it will be wrong. Then when you substitute zeros in the numerator and denominator with respect to this limit s tends to 0, at that time also you have to be careful. Okay, you make sure that you cancel out all the s in the numerators and denominators and you are putting the zeros in the right places, okay, and then you will get the result. So this is the question. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.